pigeonhole principle. The pigeonhole principle is actually best stated just using the examples of pigeons and pigeonholes. So let's go ahead and draw up 9 pigeonholes. So I'm just going to draw a grid, and each one of these boxes represents a pigeonhole. And if we had 10 pigeons, all fly to all of these pigeonholes, there is actually a statement that we could definitely make. And that statement is that at least one of the pigeonholes would contain 2 pigeons, at least 2 pigeons. So you can think about the best case scenario where a pigeon goes into each one of the holes, and that only accounts for 9 of the pigeons, and the leftover pigeon must go into one of the holes, so we can at least say for sure, with certainty, that at least one pigeonhole contains at least 2 pigeons. So how can we use this for other examples? Let's consider a big room with 367 people. 367 people in one big room. What can we say about all 367 people, or something about the people, especially with their birthdays? So you might notice that 367 is pretty close to 365, the number of days in a year, or 366 if you're including a leap year. Now, best case scenario is that 366 people in this room have different birthdays. They all have different birthdays. So this is if you're including the leap year, February 29th as a birthday, which means once we add the 367th person, we can say with absolute certainty that at least 2 people in that room share a birthday, using the pigeonhole principle. Let's look at another example. Let's say we have 121 guests at a wedding, and there are 20 tables. First question is we want to prove that there is at least one table with 7 guests on it. Now, if we're proving there's at least one table with 7 guests on it, it might be just best to consider 6 guests on each table. And I find using the pigeonhole principle that thinking about distributing everyone as evenly as possible is a nice way to go about it. So if we wanted to distribute 6 guests amongst 20 tables, 6 guests on each table with the 20 tables, that's going to take 6 times 20, which is 120 people. So the best way to spread out all the people amongst the 20 tables is to put 6 people on every table. Then, by adding another guest, that confirms that at least one table will have 7 guests on it. Let's look at another question. And how many guests would need to attend the wedding if there was at least one table with 10 guests? So because we're talking about one table with at least 10 guests, we should think about filling up all the tables with 9 guests. How many people would it take? So if we had 20 tables, all with 9 guests, that would take 180 guests all up. Then if we wanted to have just one table with at least 10 guests, all we need to do is add in another guest. So it would take 181 guests to confirm that at least one table would have 10 guests on it.